absolutely. We've got a number of cameras on board, and actually some of them will be filming during the descent. And so we're not going to get those back in live time, but at some point we will be able to watch the descent as the rover saw it. And then we've got a number of cameras on board, as I said, that will take images of the surface, and we even have one that has movie capabilities, which is something that's new for this mission and is super exciting for someone like me who studies things that move on the surface, because we actually can capture that in action. So we'll get a lot of great images. We've got similar cameras to what we had on the Curiosity rover, which has returned really stunning images from the Martian surface. So you should be expecting to see lots of great images of Mars soon.
Awesome. I can't wait. And we are about 2 hours and 43 minutes away from landing. And as soon as we're done with the live chat, we'll hand it off to the NASA TV coverage. So that's coming up here at about 2:15 Eastern time. So make sure you stay watching for that, because there's going to be all kinds of great stuff coming out today. We've got another question that came in. Are there any science packages on the Sky Crane that will survive the impact?
Great question. I do not know of any. It makes a pretty hard landing on the surface, so I don't think that anything could survive that. The Sky Crane's real purpose is to get that rover down to the surface safely, and hopefully that will be achieved. And if it crash lands somewhere far away, that's the goal.
We have our next question is. How does the Mars rover communicate information back to us on planet Earth? This is it's an email from a homeschooler. I'm not sure I know that John is having some issues with the internet. So if John can answer, that's great. If not, Mariah, will let you take that one as well.
See if John can catch up, maybe.
I think we're trying to get John in another way. So Mariah, go ahead and we'll get John back here in just a second.
Absolutely. And I'm so sorry. I have actually totally forgotten the question.
The question is, how does the Mars rover communicate information back to us on planet Earth?
Yes,
absolutely. And it doesn't take just a second. It takes a while, doesn't it?
It does take a while. So as I said, there is a delay in the time that the rover collects information and when it can get back to Earth. It depends on how far the planets are from each other. The rover has a couple antennas on board. And so technically, those antennas can send information directly back to Earth. But when we're doing sort of normal surface operations, we often have a lot of data that we're trying to transmit. So we often use the orbiters that are around Mars to transmit information back. So the orbiters that we've got around the planet can cross over where the rovers are on the surface, and they can transmit information to one another. And then the orbiter can send that information back through the Deep Space Network to antennas here on Earth, and then that gets transmitted to JPL. So it does take a little bit of time, and sometimes when we call into planning on any given day, sometimes you can watch the data trickle in as you're sitting there. It takes a bit of time, but we've got sort of a system in place that allows us to get that data back as soon as possible.
Awesome. Well, we've got folks tuning in from all around the world. We've got Hawaii, homeschoolers in Gulf Shores, Alabama, South Carolina, Colorado, Illinois, Amsterdam, Tasmania in Australia, England, Slovakia, Chile, New York, West Virginia, Brazil, Ontario. Thank you all so much for tuning in. We really appreciate it. Mariah or John, it looks like we've got John back now. We've got a question here from Elise in Scotland. How likely is a Perseverance rover to help with human missions to Mars? Mariah, you want to take that one?
Yep. Yeah, I got it. So one of the primary mission goals actually is to help prepare for human exploration. And this is a part of the mission that I'm particularly excited about. All prior robotic missions have been sort of paving the way for humans. We send robots to the surface to scope out what's there, test the environment, see what humans would have to work with and would have to deal with on the surface. And so that's sort of a precursor to sending humans. But this mission in particular is actually really going to make that happen. There's an interesting new instrument on board called the MOXIE instrument. And what this instrument does is it takes in the atmosphere, the carbon dioxide atmosphere on Mars, and it tries to turn it into oxygen that can be used by astronauts on the surface and can be turned into propellant to launch back off the surface. Human missions are really on the horizon, but they do require a lot of planning. And in order to decrease the amount of material we'd have to bring from Earth to Mars to sustain these astronauts on the surface, it's important to try and figure out how we can use the resources provided by Mars and by the atmosphere and by the rocks, how we can use those to our advantage to decrease the amount of material we have to bring from Earth. So MOXIE is one of those instruments. Another one is RIMFAX. This is the first ground penetrating radar being sent to the surface of Mars. And RIMFAX and other radar instruments could identify subsurface ice that might be able to be accessed and used by astronauts on the surface. So that's another one. This is all falls under the category of what's called in situ resource utilization. So ISRU, these are potential ISRU instruments that can really enable human exploration of Mars in the future.
We've got a lot more people from watching all over the world. Moscow, Augustine, Florida, Middle Creek Academy, Ecuador, students at Sussex Charter School, Empire High School in Tucson, Arizona, Oregon, Colombia, United Arab Emirates, homeschoolers in Toronto and Alberta, Puerto Rico, United Kingdom. Our next question, Mariah, is how many rovers are there right now on Mars?
That's a great question. So Perseverance will be the 5th. It started with Sojourner, who was a technology demonstration actually on the Mars Pathfinder mission. And I heard John refer to it in the Smithsonian Channel documentary the other day as a microwave on wheels. It was a very small rover, and it was basically sent there to test out whether we could rove on the surface. And it was successful. It didn't travel very far. I think it only got like tens of meters away from Mars Pathfinder, but it proved that we could do that. And so then subsequently we sent the Mars Exploration rovers, Spirit and Opportunity, and then the Curiosity rover, and now Perseverance. So, and they've gotten progressively larger over time. So we've got a couple roving objects now on the surface.
All right, well, the weather here near Washington, D.C. is not good today. We've had sleet all morning, and it's starting to pile up, and snow's coming in later. But it's a beautiful day for a landing on Mars. And we've got some students in Virginia who are learning about Mars on their snow day. Thank you all for joining us. We've also got the Navajo Nation in Arizona, Westmount Public Schools, Laurel Hill Primary first grade class in South Carolina, as well as the Netherlands tuning in. So thank you all so much for tuning in. And be sure to let us know what questions you have down in the comment section on Facebook. You can give STEM in 30 a follow on Twitter and submit a question there. Also, you can go to the website and follow us there as well. So, Mariah, we've got another question that's come in. How long will Perseverance operate, and what happens once it shuts down?
Yeah, another great question. I think the nominal mission is at least one Mars year. But we've seen in previous missions that these missions end up lasting a lot longer than they were designed for. I think Opportunity was planning for a 90-day, 90-sol mission and lasted 15 years. And the battery power on the rover can last up to 14 years, I think. So it could be much longer, and hopefully it will be much longer than that one Martian year, which is about 2 Earth years. But that's sort of the nominal mission. And once it's done, hopefully it has placed samples, a Easter egg hunt on the surface for the next rover. And then it'll just stay there in Jezero Crater or possibly outside, depending on how far we get in our traverse. But it'll wait there until the subsequent rover comes and picks up those samples that it cached.
Mariah, you were talking about samples, and we've got a question from Facebook, and they would like to know, what are you going to be looking for in the samples that you collect?
This is a great question, and something that's been discussed a lot on the team, and will continue to be discussed as we kind of see what's on the surface and actually get a sense of what we will be able to bring back. We've got about 30 sample tubes, I think, so we've got a good amount of things that we can bring back. but we're looking for a diversity in samples, a diversity in rocks. One of the primary mission goals is to search for ancient signs of life. And so we're particularly interested in getting samples from this delta that's preserved on the surface where water used to flow. And so taking samples of that rock, of those rocks, and bringing them back and sampling them testing them in laboratories here on Earth. We've got a lot more instruments, and where maybe 10, 15 years down the line, we've got new instruments that we can't use today. We will be looking for signs of ancient life in those samples, and we'll also be testing the mineralogy. There's a lot to learn from them. And also for human exploration, we'll be looking for if there's any kind of hazardous material in the soils. There's often been thoughts that Martian soil has what's known as perchlorate, which is potentially poisonous for human astronauts. So things like that are going to be really interesting to look at. Also looking at the composition of dust, which is pervasive across Mars. There's lots to be studied, but deciding exactly which rocks to sample and which to pass on is going to be a really, really interesting thing for the team to have to decide and work together to figure out the best set of samples to send back to Earth.
All right, well, we've got folks tuning in from the Dominican Republic, Casablanca, Morocco, Denmark, South Africa, Cyprus, the Arizona Science Center, Edwin Parr Composite High School, and homeschoolers in Alaska. Thank you all so much for tuning in. Let us know where you're watching from, and we'll try to give you some shout outs throughout the rest of the show. Again, we are going right up until NASA TV takes over the coverage at about 2:15 Eastern time. Mariah, we've got another question that's come in that I had never thought about before, and I think this is a really cool question. Can the previous rovers communicate with each other or with Perseverance once it gets there?
That's a great question. I've never thought of that either. I don't know. I think you'd have to ask the engineers. I think theoretically it seems like it could be possible. They are pretty far away from one another. So whether or not they'd be able to communicate directly, I don't know. But whoever sent that question in should look it up and tell us the answer sometime.
Well, congratulations. You actually stumped our expert, and we love that here at the National Air and Space Museum. We've got people watching from Mexico City, Walden Public Schools in Canada, South Dakota, Alberta, Maine, Iran, and India. And our next question, somebody from Costa Rica would like to know, how will this rover's exploration be different from past ones?
A great question. So there's a couple things that distinguish it. Every mission that we do on the surface is different and has kind of different primary science objectives. The Mars 2020 rover will be in a particularly interesting place on the surface, in Jezero Crater, where we know there was this intercrater lake. There's a delta and an inflow channel on the west, and then an outflow channel on the east. So we know that it was a really dynamic system and one that has the potential to actually maybe host life in the past. So this location is something that really distinguishes the mission. And then I also think the payload that's included on the spacecraft is really something new. And even though you might, just looking at it, think it looks pretty similar to Curiosity, and some of the instruments have definitely been adapted from what we have on the Curiosity rover. A lot of instruments are totally new and things that we've never tested before. The Ingenuity helicopter, which the rover is bringing along with it, the technology demonstration is going to be trying to do the first powered flights on another planet. And so this will be happening pretty shortly into the mission. So this is entirely new, and we're really eager to see how this thing flies. Flying a helicopter on Mars is not an easy thing. And so we'll be paying close attention to that. But I think there's a lot of new stuff that's going to happen with this mission. So stay tuned.
So exciting. And we are about 2.5 hours away from landing. We've got about 40 minutes left in this live chat. So please put those questions down in the comments or at Stimmin30 on Twitter, or email us as well. And we will get to as many of them as we can. Mariah, the next question that comes in is, if we find evidence of life on Mars, then what?
Great question. Well, that would be incredibly exciting. And I think that it would give us another direction to go in our exploration of the planet if we finally kind of find life on the surface. There's going to be a lot of planning, I'm sure, that then goes into things that something that's called planetary protection, which is making sure that anything we bring back to Earth isn't going to contaminate the species here and bring back something harmful. And the other way around, we want to make sure that we didn't accidentally bring anything to Mars that then looks like life on the surface. And so we want to make sure that it was real and organic life that formed on the surface of Mars. And then we would dive into how did it get there? Where is it? What kind of life form does it seem to be? I'm not an astrobiologist, so I probably won't be answering those questions, but I'm sure there will be a lot of work that goes in if a discovery like that was made.
All right. Well, we're talking about a rover that's millions of miles away on Mars and communicating with it. And our communication's been a little spotty today, but I think we have John Grant back. John, are you there? All right, we've got John back.
I think my internet is not as reliable as the one from Mars.
Well, John, we're glad to have you back. How excited are you about this landing?
I'm very excited. This is something that only happens every 7 or 8 years in terms of landing on Mars. And I think, as Mariah has done a wonderful job of pointing out, we're really on the threshold of starting to understand whether or not there actually could be life on Mars, or has been in the past. So this is something that's got a lot of people's interest.
So I want to point out that we still have a lot of people watching from all over Dubai, Norway, homeschoolers in Wisconsin, California, Budapest, Hungary. Let's ask John, since you're back, the McNally family from St. Louis, Missouri. How soon after the rover lands will they launch the helicopter?
Well, once the rover's down on the surface, there's a lot of sort of checkout and testing that needs to be done to make sure that everything survived the landing. So it won't be in the next day or two. It'll be a little bit down the road. But I'm pretty sure, given all the excitement and interest, that when that is about to happen, everyone will know about it. So you'll have an opportunity to tune in.
And I'll add to that it should be pretty early in the mission, because it's not easy for the rover to drive around with a helicopter attached to its underside. So it shouldn't be too long before we have to wait to see those happen.
I can't wait to see those. We've got a fourth grader doing online learning that says they're so ready to see the landing. What's the best way to keep following it? And I know that we can pull up the NASA website that has the countdown to landing on there. You can head over to the NASA website. We will be live here until about 2:15, and then NASA TV will take over that coverage. And the rover touches down at 3:55 Eastern time, which is about 2 hours and 26 minutes away. John, another question that has come in: how and where is the rover tested before being sent to Mars?
Well, it's tested where they assemble it out at the Jet Propulsion Lab. And then there's a final checkout process that occurred down in Florida at the Kennedy Space Center before launch. But many of the components are actually tested as they're being designed, like the parachute and other things are checked out in various locations before they're actually assembled into the completed rover. This is truly a group effort. There are many, many different people that have come together and provided various components of this rover to make something that, once it's all together, gets at these questions of whether or not there could have been life on Mars.
A next question we have, and I'm going to throw this at John again, because I know we've discussed it.
Give Mariah a break.
She can catch her breath. What made this landing site in Jezero so promising? What is it about that area, and how did we choose it?
Okay, well, I'll start with the second part of that first. We actually had a very long and involved process, about 5 years long, where approximately 30 different candidate landing sites were considered, not only by the science team, who makes the ultimate recommendation to NASA and who picks the site, but also by the science community. They brought everybody in and said, if you were going to go with one place to try to bring samples back, to try to find out if there's life on Mars, where would you go? And we whittled down that list and arrived at the Jezero crater site, by and large, because there is a large river delta that we see entering from a valley that cut through the western rim of the crater that you can see here in this image. And the circle, which is the landing site for Perseverance, is kind of right on the edge of that delta. And what's important is that the sediments that were carried down in that river were deposited out on the floor of the crater, and then that delta grew out across it and sort of preserved them. And what we call the bottom set beds, the layers of sediment that are right at the base of the delta, that were in a lake that were before the delta grew out across it, are the place that we might be able to preserve, if they were ever present, the kind of biosignatures that would let us say something about past life on Mars. So Jezero is really unique in that sense, that it's got this well-preserved delta, these access to these kinds of layers of sediment, that we think can answer those questions.
Awesome. Well, we've got folks tuning in from Germany, Sweden, Cumberland Valley Virtual Academy, Saudi Arabia, and the Philippines, where it's 2 a.m. Thank you all for tuning in. And the fact that I keep coming back to that kind of blows my mind is that right now, until we discover life, Mars is the only planet we know of completely inhabited by robots.
And we mentioned earlier that we're going to share some resources with you today so you can learn more about Mars and the fleet of robotic explorers we have sent to the Red Planet.
STEM30 has produced a lot of videos on Mars, and we've created a Mars playlist on YouTube. There you will find a whole bunch of videos about Mars, including interviews with experts, animations, and astronauts telling about future journeys to Mars.
Our friends at the Smithsonian Channel have also created a couple of amazing resources. The first is Making Tracks on Mars, the Smithsonian Channel's mission critical special that goes into detail about the entire Mars 2020 mission.
Drawing on the resources and research that went into this special, they have created Mars AR, an augmented reality experience. This thing is cool. Interact with Percy and its rover predecessors, and even drive the rover and fly the new Mars helicopter.
So we have still got a lot of people watching, a lot of questions coming in. We've got people in Spain, Argentina, Trinidad, Guantanamo Bay Naval Base, Serbia, Poland, France, Colorado, and homeschoolers in California. Our next question is, what happens if something goes wrong in the entry, descent, and landing system? Are there any backup plans for that?
I don't think either one of us wants to take that one. No, there is no backup parachute. There is no backup sky crane. But I think your earlier question about the testing that goes on and the design that goes into this instills a sense of confidence that this is a very robust landing system, or as we say, entry, descent, and landing system. And let's not forget that the Curiosity rover, which is operating on Mars, used a very similar process for getting down on the surface. So we do have that sort of heritage to draw on.
All right, well, we've got folks watching from all over the place. If we haven't given you a shout out yet, be sure to let us know where you're watching from. You can either let us know in the comments section on Facebook or at STEMin30 on Twitter, or email us stemmin30@si.edu. And we'd love to know where you're watching from and what questions you have for Mariah and John. And our next question comes in. They want to know, how is Perseverance and Ingenuity situated? Or is Ingenuity on top? Is it at the back? Where is it?
Yeah, so Ingenuity is kind of right underneath the rover. They made it very small, I think, for that reason, and because it's hard to fly in the thin Martian atmosphere. So it's only a couple pounds, I think, 6 pounds, but it's sort of situated underneath the rover, and the rover will drop it off on the surface and then drive away, and then the helicopter will try to take flight.
We've got Avery from Connecticut, and this is a question that both of you can answer. Avery would like to know, do you have a favorite part of the rover, and what is it and why? So let's start with John, since he's laughing.
You know, My involvement in some of these rover missions goes back to the spirit and opportunity. And I think that my favorite part would be the mast and the cameras up on top, because after you've worked with these for a while, you start to almost see them as living beings. And to me, those are sort of, that even though the brains are kind of down inside the rover, when you look at the rover, that kind of looks like the eyes and head. And to me, that's the sort of part of the rover that's most lifelike.
What about you, Mariah?
Yeah, there's so many great instruments on board. I think I'd have to say one of my favorites is definitely that Moxie instrument that I was mentioning before. This is an entirely new instrument, and it's really trying to pave the way for human exploration by turning the atmosphere into something that we can really use. So I think that that's an incredibly useful thing and is really innovative, and it's going to be exciting to see how the Moxie experiments go. I think the other one is the meteorological sensor, which I'm biased. I use that sensor for data for my studies, and so it's one of my favorites for that reason. But it's really important that we understand the environment on the surface, and so the META instrument, it provides information on the temperature, on wind, on pressure, things like that will also help prepare for human exploration by telling us what the surface conditions are and what the environment is like and how these things change over the course of the year. And so it's a dynamic system, and META helps us understand that.
Awesome. Well, we know we've got a lot of schools watching today. Thanks so much for tuning in. We'll go up until about 2:10 today, and then the NASA coverage starts at 2:15. So make sure that you're watching NASA TV when their coverage starts. We've got Mrs. DeSalvo's fourth grade class in Temecula, California watching. And this question, I think, follows up on all of these schools that are watching. From Macon, Georgia, they wanted both of you to talk a little bit about your educational background and what do you have to study to start working on Mars? Mariah, let's start with you.
Yeah, so I grew up in Boston and went to Brookline High School, and was always sort of interested in math and science, but didn't quite know how that would play out moving forward. When I went to undergrad, to college, I studied astrophysics, and so that's how I sort of got into the space field. And then after that, I sort of decided I loved space and I loved studying space, but I wanted to do something a little closer to home. And so Mars was sort of that happy medium where I was working in space exploration and getting to work on space missions, but studying an object that was closer and that we could actually touch and see. And so it was sort of that happy medium. I think there are a lot of great things, a lot of different types of things that you can do to get involved in planetary science. I mean, we have a lot of different disciplines that are represented on the team. People that study astrobiology, geologists, atmospheric scientists, all sorts of different things. And so it's really about finding what you're passionate about and pursuing that.
John, how about you?
I grew up in far northern New York, a town called Plattsburgh, and there's a lake up there called Lake Champlain. And growing up along the shores of that lake, it was a wonderful opportunity to learn about the landscape, to learn about the rocks and how water shapes the landscape. And so when I went on from high school to college, I went into a geology program and learned about how the world and the earth have evolved over time. When I went on to graduate school, I worked with a man that had a small grant doing work related to mapping a portion of Mars. And I kind of scratched my head and said, I had no idea that you could do this sort of thing. And that was sort of the switch that got turned on. I helped him with his map. I went on then and got my PhD. But like Mariah, I would echo that a very important component is the math and science that allows you to build on the information that you're seeing in the landscape around you and provide you with the tools to interpret how it has evolved over time. So I think it's a kind of parallel track to what Mariah took, but there's little differences. And I guess what I would point out is while I took a track that was largely in geology, and Mariah, I think she's being modest, she's got a degree in astrophysics, but she's also very interested in how the wind shapes the landscape around her. Yet through these various backgrounds, we've all come together and work on the same projects together. So you can come at this from a variety of different angles, but I think the core is a strong basis in math and science.
As a former teacher, I love hearing what you both said. And Mariah, you mentioned following your passion. And one of the things that I've gotten to do while working on STEM and 3 is talk to some incredible people. And one of the things that they always say is to follow that passion, whatever it is. And during the broadcast today, you've seen some amazing NASA animations, and those are done by people that their passion is animating and making computer graphics. And there's got to be people that make the food for the astronauts on the space station. So whatever your passion is, follow it, and you're going to be happy no matter where you end up. And I think Mariah and John are great examples of that.
We've got still a lot of people watching from all over: Switzerland, Belize, Ireland. Federal public defenders are watching in Philadelphia. So that just goes to show you the wide variety of people who are interested in the Perseverance landing today. We have another question from Miller Middle School in California. They would like to know, how does the nuclear reactor on the rover work, and how does it power the gadgets on board? And the other thing I'd like you all to discuss is the difference between nuclear power is kind of new for these. We were using solar power, and maybe why did we switch?
Mariah, you want to take the first and I'll take the second?
Yeah, sure. So we have on board what's known as an RTG, radioisotope thermal generator, I think. And so basically we've got plutonium on board that decays into electricity that we can use to power the instruments. And yeah, as you said, we've also used solar panels before, and so maybe John can go into that. He worked on the MER rovers, which use those as well.
Yeah. So with solar power, obviously you're depending on the sun shining on the solar panels to provide you with the electricity. And one of the things that we know about the environment on Mars is it's dusty, and at certain times of the year it's quite a lot dustier than others. And you can see a picture now of one of the Mars exploration rovers. This is actually when it's looking fairly clean. So over time, as dust builds up, the amount of power that we get is reduced. With the Mars exploration rovers, it turned out that we got very lucky. Whirling sort of dervishes in the atmosphere called dust devils would come along every so often and blow off a lot of the dust, and we'd get that new rover smell back again, and a lot of power. The InSight lander, which is still operating on Mars as we speak, also has solar panels. And there is dust that's been building up on those solar panels over time as well. We haven't been fortunate enough to have a large enough dust devil come by to sweep the dust off there. So both kind of power sources are being used. I think there's advantages and disadvantages to both. It really comes down to the kind of mission you're doing. Do you need to do things at a higher latitude where the sun may not be shining as much during part of the year, those sorts of things.
Awesome. Well, we are about 2 hours and 11 minutes away from the Perseverance rover touching down on the surface. And we've got Sophie from Spain wants to know, how fast are the rovers and how do they compare to the other ones? Are they doing wheelies on the surface?
John, you want to take that?
Sure. You know what? Strangely, they can kind of do wheelies on the surface. And by that, I mean, you can actually lock up some of the wheels and then turn the other ones and sort of lift, they're all sort of an independent independently driven. You can actually kind of pop one up or something. Having said that, if you were walking on Mars, you would very, very quickly go right beyond the rovers. They're not moving that fast across the surface. To give you some sense, if there's no obstacles in the way that we have to go around, a really good day of driving on Mars is on the order of 150 to 200 meters. So somewhere on the order of 1.5 to 2 football fields. To give you a sense of the distances that we can go in a single day.
And just to add to that, one of the new things that Mars 2020 has is that it's got some new technology that's going to allow it to drive autonomously a little bit further than Curiosity has been able to in a given drive. So even though they're moving pretty slowly, hopefully we'll be able to make a little bit more progress each day.
To follow up on that question, somebody has asked, what's the difference in the wheels of this rover. Now, I know that there were some changes because we've learned some things from past rovers. John, do you want to tell us a little bit about that?